Today we are going to teach selection sorting. In selection sorting, we are going to move the largest or smallest element to the end until the data is all in order. And in this example, we are going to sort the Family Guy characters from shortest to tallest. So first what we have to do is take Peter Griffin, who is the tallest, and swap him with Brian's place, because he is in the fifth variable, and since Peter is the tallest, he belongs there. So first, we're going to have to move Brian to a temporary variable so that Peter can replace his spot and Brian can take Peter's spot.
So I have three classes here basically. I have the mother class, which is shapes, and then sentence and character extends this shapes class because they also have, like you can see, they have x, y, width, height. So they inherit those properties in the super. So basically the sentence one controls this text over here that scrolls and prints out like that. And the character class obviously controls the images that you can see of the characters over here and this guy. And also the moving function, the method, I mean. Alright, so now I'll explain how the program works. So basically, it's working on a step pattern, as you can see here in the code. And every time you press a key, the step moves forward by one. And like you can see, the text forwards by one step. So after he explains a little bit, he shows how it's sorted. So like Lucas said, the first thing to do is select what the location of the biggest data point is. So that's going to be the second index where Peter is. And so he's going to have to be swapped with Brian at the end because that's how we're going to eventually sort it by moving the biggest object to the end of the list in every increment. So yeah, the move function is like calculating the slope inside of each, like from the distance of where the character is and where they want to be. And they use the absolute value of the x to determine whether it needs to move up or down. Um, so yeah, it basically is executing what's happening in the algorithm right here and what's circled. So it'll keep on going. Like Lois is already where she needs to be, so she won't be moved. It'll just move on. Then like the same thing will happen like that happened over here. The biggest index will be moved to the whatever the end index is currently.